Hello friends, welcome to EC Academy. In this lecture, let us understand a very important concept in network theory, which is initial conditions in the circuits when we are using resistors, inductors and capacitors. So what is initial condition? Whenever we consider a circuit and when this circuit is switched on at time t is equal to 0, we want to know what is happening just before switching, which is represented by t is equal to 0 minus, and also we want to know what is happening just after switching, that is represented by t is equal to 0 plus. So here you need to remember just before switching is represented by t is equal to 0 minus, and just after switching it is represented as t is equal to 0 plus. Now let us consider a circuit with voltage which is represented by E and a resistor R along with a switch that is represented as t is equal to 0. Now at steady state, we can write the current flowing through the circuit I will be equal to E by R using Ohm's law. Now let us understand the behavior of the circuit. Now at t is equal to 0 minus, which is just before switching, this switch will be open. If this switch is open, no current flows through the circuit. So the current will be equal to 0. Now at t is equal to 0 plus, which is just after switching, this switch will be closed and current will flow through the circuit. So at t is equal to 0 plus, the switch will be closed and there will be current flow. And this current will be equal to I is equal to E by R. So we can say when we are using a resistor in a circuit, there will be instant change of current that happens. So there will be an instant change. So you need to remember when we are using a resistor, it allows instant change in current and there will be no delay or no memory in the circuit. Now let us consider the inductor circuit, which consists of resistor as well as inductor along with a switch where the voltage E is applied. So this circuit is very important in solving the problem. Now let us apply KVL to the circuit. If we apply KVL, so we will get E will be equal to I of t into R plus L di of t divided by dt. Now let us understand the behavior of the circuit. Now at t is equal to 0 minus, let us assume the relaxed circuit, which means no initial current is flowing. So just before switching, where a switch is open, the current I0 minus will be equal to 0. At t is equal to 0 plus, when switch is closed, the current in the inductor cannot change suddenly. So this is very important rule that you need to remember. When the switch is closed, the current in the inductor cannot change suddenly. Therefore, the current I of 0 plus will also be equal to 0, which is same as I of 0 minus. So from this we understood that at t is equal to 0 plus, which is just after switching, the inductor will behave as open circuit. So why it is acting as open circuit? Because in inductor, current cannot change suddenly even after switching. Now if we consider the inductor circuit along with the initial current I is equal to I naught, which means before switching I0 minus will be equal to I naught. Then after switching I0 plus will be equal to I naught. So in the previous case, before switching current was 0. So after switching, the current was also a 0 because there will be no sudden change in current in the inductor. Now, if there is an initial current that is flowing through the circuit which is taken as I naught, even after switching, the same current will flow through the circuit. Hence, if there is an initial current, we can replace this inductor with a current source, and this inductor will act as a open circuit. So this concept is very important for solving the problem. Here, the inductor will be open circuit, and we can replace inductor current by the current source I naught. So this is very important concept. Now let us consider the capacitor circuit, which consists of resistor and capacitor along with a switch with voltage E. Now let us apply KVL. So we'll get E will be equal to I of t into R plus 1 by C integration of I of t dt. Now at t is equal to 0 minus, which is just before switching, there will be no capacitor voltage. Therefore, voltage across the capacitor just before switching will be equal to 0. Now, at t is equal to 0 plus, which is just after switching, the voltage across the capacitor cannot change suddenly. So Vc 0 plus will also be equal to 0, which is same as Vc 0 minus. Why? Because voltage across the capacitor cannot change suddenly. So at t is equal to 0 plus, the capacitor will act as a short circuit. Now, in capacitor circuit, if capacitor is having some initial voltage which is equal to V naught, then Vc 0 minus will be equal to V naught, that is just before switching, and after switching, the voltage across the capacitor cannot change suddenly. That's why Vc 0 plus will also be equal to V naught. So we know that after switching, the capacitor will act as a short circuit, and we can replace voltage across this capacitor with a voltage source of V naught. So we can replace with voltage source V naught. So for this circuit, if we apply KVL, we'll get E will be equal to I of t into R plus V naught. So here, if we have reverse polarity, which means if we have minus then plus, at that case, we can write E will be equal to I of t into R minus V naught. So this second case of equation is for the reverse polarity. Now finally, let us summarize. This is very important for your exam. When we consider the resistor as an element, there will be no effect on the resistor, and after switching, the behavior of the resistor will remain same. When we consider an inductor, here current cannot change instantly and it will act as open circuit. And when we consider a capacitor, here voltage cannot change instantly and this capacitor will act as a short circuit. And always remember, the inductor current is continuous and the capacitor voltage is continuous. So today we understood what is t is equal to 0 minus and t is equal to 0 plus, how resistor, inductor and capacitor behave, and how to replace them in the circuit. Hope you have understood this topic. Thank you.